12 kids, obviously, in elementary school, so it clearly be a statistic. Very good. So what's the mean and the median? The mean is 273. What was it again? 0.75. And what's the median? 285. Okay, what's the standard deviation? 113.80. I can't hear you. Okay, did you get the data in your list? Yes? Okay, it's in the list. It's right there. So do you have it in your list? So go one variable stats and in that list. Did you get them all in there? Did you get it? Good. Sure don't want to miss that, right? Okay, so the question is there any skewness to the data? How do we know skewness? What do we check?
These are all like separate.
We're going to go to Pearson's index, right? We'll go to Pearson's index, right? Pearson's index says what? 3 times the average minus the median divided by the standard deviation, right? Remember that? So what's the average? 273.75 minus 285 times 3 divided by 113.8. So 273.75 minus 285 is 11 and a quarter times 3 minus 11 and a quarter, right? Divided by 113.8. So 3 times 11 and a quarter is negative 33.75 divided by 113.8. And that number is clearly going to be what? Less than 1, right? It's clearly going to be a decimal number. And Pearson's index says if Pearson's index is between negative 1 and 1, there is no substantial skewness in the data. Okay? So there is no substantial skewness in the data based on Pearson's index. Okay? So do these values indicate any skewness in the data? No. Well, if they're not exactly equal, there's a slight amount of skewness, but there's not any substantial skewness. Okay, is everyone okay on that? Okay, good. Determine the standard deviation. We got that. What does that measure? That's how far the average person is away from the mean, right? It's kind of how far each person on average is away from the mean. So some are 200 marks away, some are negative 100 marks away, but on average, the average person is 113.8 marks away from the mean as a matter of distance. Could be above, could be below. Okay? Make a stem and leaf plot of the data. Make a stem and leaf plot of the data. How do we do that? Well, it didn't say any specific thing for our stem or any specific thing for our leaf. So we'll use the 0, 1s, 2s, 3s, and 4 tens places for our stems. Okay? So these are our stems. The question then are, what are our leaves? Okay, what are our leaves? Okay? So all we simply do is fill that in for our leaves. Now, are you taking the test now? Okay. One problem, 3. All right. Which one we're on? So first one's 250. So it goes right here. What's the one after 250?
400.
400. What's next?
350.
350.
290.
290.
235.
35.
50.
50.
200.
200.
120.
120.
360. 360,
360,
280,
280,
450,
450.
300.
There's our data stemming there. And you can see that does look reasonably bell-shaped based on those 5 spots. One can argue how bell-shaped here. Pearson says it's reasonably symmetrical. Okay? Everyone okay on that? The next one. Make a frequency table of 3 classes for the data. Make a frequency table of 3 classes for the data. So now what we have to do is we have to figure out our class width, right? We have to figure out our class width. So how do we find our class width? There you go. So it's a high or the max minus a low or the min divided by the number of classes. In this case, that's 450 minus 50 divided by 3. So that's 400 divided by 3, 133.3. Right? 133.3 then would be our class width. And what do we always do? Round up to 134. So our class width then is 134. I'm sorry? It says with 3 classes. Okay? If it said 4, you have to put 4. 5, you put 5, whatever it says. In this case, it says 3 classes. Okay? So my first class would be from what?
0 to 134?
So it would be from, we start at our lowest point, 50.
Oh, sorry.
That's all right. So this would be 184, and 134 to this would be 318, and 134, so this would be to 183. This would be to 317, and this would be to 451. You want to see how I got those 3 classes? I want to see how we got the 3 classes. Start out at the smallest point, and you simply add your class width to each one to get your starting point. Okay? I don't think they'll ask you for the midpoints. We'll do it just to make sure. So we'll let you. All right, so now we just have to clip them in here. My first data point was 50. My next one's 120. My next one is 250. My next one is 290. Next one is 235. Next one is 200. Next one is 280. Next one is 350, 360, 300. Next one is 400. Next one is 450. Anyone see that? So for the first class I had 2. The next class I had 6. Last class I had 4. Always make sure that those add 12 total number in the class. Everyone get that okay? So there's our frequency. Make a relative frequency histogram for these times displaying midpoints. They do. Midpoints along the horizontal axis. So we have to find. I'm sorry?